Welcome to the first lesson here that we have. As the module outcomes or the week outcome said, we need to be able to convert things to engineering notation. Now, some of you I know are familiar with this, but other people have probably never seen engineering notation before. But the reality is engineering notation is just a modified, well, let me get my pen out here. Oops, wrong button. That this is just a modified version of scientific notation. And I'm not going to take a lot of time to review scientific notation. Hopefully we all have done scientific notation before, but just to kind of remember here, so if you have like a number of 3,124, you could write this in scientific notation as 3.124 times 10 to the third power. And remember that times 10 to the third power is telling you that 3 is telling you, okay, well, you'd be moving this decimal place 3 spots to the right. Or another way, the more mathematical way to think of it is that you have 3.124 times 10 to the third, which is just times 1,000. So 3.124 times 1,000 gets you to 3,124. And then, of course, we also have this going the opposite direction. So if I look here at this number, this would require us using a negative exponent. And so if I want to move my decimal point, again, I would move it here. Let me choose a different color here. I'll just stay here for a second on this view. I would move it 1, 2, 3, 4, 5, 6 spots to the right. And so this would be 1.56 times 10 to the negative 6th power. And again, you can think of this is tenths, hundredths, thousandths, 10,000ths, 100,000ths, and then millionths. And 10 to the negative 6 would be millionths. And so that is again how we could write that in scientific notation. Now, the reality is often in electrical engineering, we just want everything to be in scientific notation, but we don't like having to always write this times 10 to a power business. And so engineering notation kind of has come up with a shorthand here. Just trying to scroll the screen here, and this new version of OneNote I don't particularly like. I used to be able to scroll the screen with just my one finger, but now it's wanting me to use 2 fingers to do the scroll. But in any case, back to this. And actually, let me just stay in this view here so I can switch back and forth. So we want to not always have to write this times 10 to the negative 6. So engineering notation does everything. First off, it does everything in powers of 3. So if we had a number, for instance, if we had 1.3 times 10 to the 4th, that's not how we would write it in engineering notation. We would want to have this in a power of 3. So you go to the closest 3 that you have here. And so if I think about what this number actually is, this would be, 1.3, and then move the decimal 1, 2, 3, 4 spots. So that would be 13,000. And so instead of writing it in scientific as 1.3 times 10 to the 4th, we would actually write this And again, using the closest 3, we'd say, okay, well, I'm going to use it 1, 2, 3. And I can't really, I could move it over another 3 spots, but then I'm going to have to write like 0 point something, and we typically don't want to do that. And so this would just be simply 13 times 10 to the third. Now, there's of course an easier way to do this than what I have shown here, is simply if you decrease this exponent, so I'm decreasing it from 4 to 3, I've got to move the decimal point over 1 to the right. Now, we have the same thing if we're dealing with small numbers as well. So if we were to have, for instance, 2.3 times 10 to the negative fifth power, well, that's not, again, in engineering notation because we want powers of 6. And we want powers of 6 that are also going to create the fewest number of numbers in front of the decimal point. And since I don't want to have like 5,624, and then times something to the third power. We want to have it so that we have as few digits as possible in front of the decimal points. So usually you have 2 or 3 digits in front of the decimal point for engineering notation. But if I were to write this number out again, not necessary to do this, but it would be 0.000023. Now again, if I kind of think of this as going in powers of 3, well, if I do 3 to start with, 1, 2, 3, well, that's still going to get me 0.023, and we try to avoid that if possible, so I'm going to go another 3. 1, 2, 3. And so what I'd really wind up with is that this number would be 23 times 10 to the negative 6, because again, everything needs to be in powers of 3 for engineering notation. Now, in addition to wanting everything in powers of 3 for engineering notation, we also don't want to have to always write that scientific notation down. And so some of these you're probably familiar with. If you've ever taken a physics class or a chemistry class, you're familiar with some of these prefixes that we're going to use. And so the prefixes I'm going to write out here, a little table here, the prefixes that are the most common ones used in engineering, at least in electrical engineering. So this will be my prefix, and then, I'll say 10 to the n power, whatever the power would be. So there is giga, which is just a capital G, is what we use, and that is 10 to the ninth. Then there is mega, which is capital M, and that is 10 to the sixth power. And then this is one that probably most of you are familiar with, kilo, 10 to the third, because you're probably familiar with kilogram, kilometer, things like that. That's a lowercase k. And then there's what I'll say just the base unit, which has no prefix. So there's no prefix for the base unit, and that would just be times 10 to the 0. So for instance, you might have 3 meters or 100 meters, but then you might have 1 kilometer again. So base units are times 10 to the 0. Then we're going to start going into the negative. Now, one that you're probably familiar with that you've probably used a lot is centi, like centimeters. But we don't use that at all in engineering because that's times 10 to the negative 2. And remember, we only do powers of 3. So the one we're actually going to do here is we're going to do milli. And this is where we have to start being a little bit careful, even in my writing here on this thing here. That's a lowercase m. So we have to be very careful, case sensitive, lowercase m versus capital M. And this is 10 to the negative 3. And then there is micro, which is a Greek symbol mu. Looks kind of like a U with a little extra branch on it here. In fact, in the circuit simulators, we use U to represent micro because we don't have the Greek letters on our keyboard easily. And this is times 10 to the negative 6. And then we also have nano, which is just n, 10 to the negative 9th. And then we might even encounter this one a little bit, pico, which is just lowercase p, which is 10 to the negative 12th. Now there are others. There's like femto, which is times 10 to the negative 15, but we probably won't encounter that. But we'll encounter all of these prefixes. And for instance, when we start talking about next week, well, even a little bit this week maybe, when we start talking about resistors, resistors have a base unit. Resistors base unit is ohms, which we actually use and that's not a well-drawn one, but it's the capital omega in the Greek alphabet. And so resistors, though, are often in circuits in the kilo-ohm range. They're usually thousands or even tens of thousands of ohms. Now, we do have some special cases where we need small resistors, like even when I say small resistors, even like a 0.1 ohm resistor or some other special purpose resistors. But typically, we're going to have resistors that are usually at least 1,000 ohms. And so, again, instead of writing 33,000 ohms for a resistance, we are going to be writing 33 point, we don't need the point there. It would just be 33 kilo ohms. And likewise, we're also going to have things called capacitors. And capacitors will have units, their base unit is a farad. Now, a 1 farad capacitor, as a side note, is a huge capacitance. And when I say huge capacitance, the capacitor itself would be ginormous. And there are capacitors that are that large. They're used in industrial applications and in power applications, like power grid stuff. But the capacitors that we'll be dealing with primarily, especially at the beginning of your career as engineers here, will be much smaller valued because we're dealing with much smaller voltages. And so they'll be in the microfarad to picofarad range. And so we might have a capacitor, for instance, that has a capacitance of 47 times 10 to the negative 9th farads. But we wouldn't write it as 47 times 10 to the negative 9th farads. We'd, of course, use my engineering notation and write this as 47 nanofarads. So that's really the basis of this particular lesson here, is to get used to this engineering notation. Now, hopefully you all recognize, I'm going to emphasize it again, that this really is just a special purpose scientific notation. It's just engineers, instead of going all possible units for scientific, we say, well, we're only going to go in units of 3. And so that's where we get the, again, kilo ohms, nanofarads, things of that nature. Okay, so that will wrap us up for this video, and we will continue on with some other things in some other videos.